Welcome to General Biology. Today's video is on carbon backbones and why carbon is the molecule that makes up most of our organic molecules, which are the ones we find in living things. So this is the periodic table, and on the top, hydrogen and helium make up the top row, and they would prefer to have 2 electrons in their outer shell. Their outer shell can only hold 2 electrons. The next row down, these molecules can hold 8 electrons in their outer shell. So to fill that outer shell, they would prefer to have 8. So boron, carbon, nitrogen, oxygen, they're going to try to pick up electrons to fill their outer shells by forming bonds with other molecules. For example, here's an oxygen. Oxygen has 6 electrons in its outer shell. It would like to pick up 2 more. Well, if it can share a pair of electrons, it's going to kind of feel like it has 2 extra electrons. For example, here's oxygen. This is O2, oxygen gas. Oxygen, by sharing a pair of electrons here, these 4 electrons orbit both, and so they kind of feel like they're going around both. So oxygen has these 4, 5, 6, 7, 8. So now its outer shell feels kind of full, and the same is true of this other oxygen molecule. So this is a more stable configuration than if we just had an oxygen atom. Here's water. Same thing's going on here. Hydrogen by itself is fairly unstable. But when you bind it to oxygen, now we have 2 electrons in the outer shell for each hydrogen. And the oxygen feels like it has 8 electrons in its outer shell. So everything feels like it's kind of topped out. And this is a really stable configuration. Carbon can bond with 4 other molecules. It can form covalent bonds with 4 other molecules all at once, or maybe double bonds with some and single bonds with others. This is an example of methane. In the situation of methane, the carbon molecule binds with 4 hydrogens. So we share a pair here, share a pair here, share a pair. So the carbon feels like it has 8 electrons in its outer shell, and each one of these hydrogens feels like it has 2 electrons in its outer shell. So this is a fairly stable molecule. This is carbon dioxide. The carbon has 8 around it. The oxygen has 4 over here and 4 right here, so it has 8 around it. So everything feels like it has 8 electrons, so these are a stable situation. Here's carboxylic acid. Carbon has a double bond here, double bond, or double bond here, single bond, covalent bond, so it's sharing a pair, sharing 2 pair, sharing a pair. And so it feels like it has 8 electrons, and it's in a nice stable configuration. This connects piece kind of resembles carbon. Okay, it can bond to 4 different things all at once. When you can bond to 4 different things all at once, you're really useful in making stuff. So this connects piece is useful in making the structure. If you had a bunch of these, you could make some pretty complicated structures. Carbon is kind of the same way in our organic molecules. It's the backbone of sugar because it can bond to 4 different things all at once. It's the backbone of saturated fats for the same reason. It can bond so many places all at once. It's the backbone of amino acids. You can see carbon, 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 carbon. It can bond lots of different places all at once. So it's a super useful molecule when it comes to building other molecules. It forms the backbone of all of these organic molecules that make up our bodies. And so we say life is built from carbon because carbon forms the backbone of all the molecules that make up life.